So we can wait for a few minutes, and if you guys have any questions, you can ask in between. For till then. All right, I guess we can start. Can I guys see my screen? Okay. So last class we discussed some basic things first.
The
Sorry?
screen is too small.
Oh, okay, sure. I hope this is better. Yeah. Okay. So last class we saw some basic um, concepts like functions, namespaces, right? So let's say I have my own user-defined cout. I can put it inside some namespace so that I avoid collision with the standard cout that comes with the standard library. Now, that's one. The second thing is calling some basic functions. You can have functions which take inputs and return with some output. Okay, you can use using namespace standard, but again, this is for better readability of the code. You should rather stick to using the full namespace. Then we saw some ternary operations, and furthermore, there was a question about the post and pre-increment operator. So that's one. Other than that, we saw a very important data structure that is used to represent a data structure called list. Okay. So standard vectors are a way of representing them in your code. A list is essentially a collection of contiguous data, and all of them need to be of the same data type. So that is what is determined by this template parameter. and you can define the sizes during initialization itself, or you can do it afterwards doing a resize. Now, the standard vector essentially keeps a collection, and because of the sizes that is determined while initializing this object or this vector, right? A, the its position from with respect to any the starting point is actually fixed. Okay, so this is what we mean when we say it's contiguous. So the data, so let's say integer, right? Usually integers are 4 bytes. So from the starting of, say it has been allocated some data, from starting from some address which is in memory, okay? Starting from some address, the first value will take 4 bytes. Then the second value that we store inside this will take next 4 bytes. So this continuous um, connection is what we mean by contiguity. Okay. And we also saw some um, functions of this vector class. Here, vector is a class. We'll learn about class and objects later on, but just so you know, it has some useful functions that we can call related to that specific object that we created. Okay. So this is the size function, right? And this keeps track of the size of the vector throughout the whole program. Now you can resize the vector and again try to print the size. And then you can also check its capacity, how much it can hold, as in how much the data has been allocated for it to keep resizing. Okay. You can always resize to much more higher numbers. So this value, but one has to be careful that that memory should still exist for the RAM to serve. Okay. Uh, so now the way one accesses these um, vectors is using this bracket operator. So essentially, there's nothing but actually a dereference operator, which one can which one can also write something like with something like this, and essentially these two are equivalent. So this bracket operation essentially goes to the ith value, okay, from some starting position, and the number of bytes it has to shift is determined by its data type. Okay, I hope this portion from last time is clear. The same thing is essentially what is written here, where this a dot data is essentially a pointer to the starting point, and you shift by some value, and then the star operator is the dereference operator. Okay, so essentially this is a pointer, and we are just using the pointers and seeking what the value is at that position and then writing it. Here we're seeking the value at this position by using the dereference operator and just printing it. So essentially these two portions of the code are essentially the same. Okay, so let's today maybe look at arrays too, because since we discussed vectors, we might as well discuss arrays too. Okay, so let's include the important IO stream that we'll use to have input and output. Okay, then include array. Okay, then this header file, essentially this header file is needed to access the array class. Like we have included vector to access the vector class. We use the array to access the array class. Okay. Then yeah. So the way you make an array is you have to put a standard array, okay, and then start the template. First, you have to give the data type of the array. Notice it also requires a second argument where you have to give the size. Okay. So unlike vectors which do not really need a size, you can actually define them like this also. This is perfectly valid code, but for an array, you can't do so. You have to actually give this size at compilation time itself. And since it's a template, it has to know the value at compilation time. Okay. So the reason for that is arrays are stack allocated. We'll look into stack and heap allocation more. I can explain it again, but just so you know, these are stack allocated. So they require the sizes to be known at compilation time. For vectors, they just need to know the sizes at runtime. You can dynamically resize them at runtime itself also. Okay. So yeah. So I declare an array, then again, I can just access those values like this. Can use the size operator, but again, one already knows the size, but anyway, plus plus. Okay. Again, you can use the dereference operator to access the values. Okay. And then you can just print them. Okay. Okay. So yeah, let's run this code now and then see. Okay. So as you can see, the output prints as expected. So we have a from 0 to 9. That's what happens when you try to print from 0 to less than size is 10. So we just fill the values and then just print it. Okay. So simple code, essentially how shows how to use an array. Slight difference between vector and arrays, but more or less a lot of these functions are similar, and working with them is also quite similar looking. Okay, so this is the reason to see arrays and vectors is this is the way you would look at sort of a heap allocation in vector case and sort of a stack allocation in array case from perspective of C++. So this is the C++ way of accessing these data structures or these classes, which is already defined in the STL, the standard tuple library. Okay, and then you try to access them. Okay, the same thing you can do it using C-style arrays also. So it looks something like this. That's it. So you have to be careful though. You can't use this inbuilt function here in this case anymore. So you have to actually give its size properly. Okay. Rest of them should be fine. So here you declare a bunch of stack allocated C-style array here. Okay. You give the data type, you pass the size. So the compiler knows how much data you want. Okay. So then if you try to compile this and run, yeah, it runs fine. Again, one has to be careful not to use the size function because here it's not a class. It's just a C-style array. It doesn't have this defined function for in its as part of its code. Okay. So that's one useful thing about using C. It's essentially the same thing, but with much more features and functionalities. Hence we use, hence the use of C++. It adds more things on top of whatever C provides. Okay. All right. Any questions so far? I think that should be clear. Okay. So let's look at pointers today. So Again, I'll just include iOS tree. Let's make a main function. Okay. Mm, okay. Let's make a constant size. Let's maybe put it 10. Okay. Then define a C style array. Okay. Now, important thing to note here is if this wasn't a constant, and it essentially like if you declare just an integer size, okay, which could vary, even later define size to be 11 or 15 or something, then this variable becomes actually a variable. So it can change its value. Such variable cannot be used to declare arrays because remember it has to be compile time constant, and here because we've declared it to be const, which says that the value of size cannot be changed uh, ever in this code at least. Now, because of that, I can actually declare my C style array like this. Okay. Now, important thing here is it is stack allocated. Okay. Since it's a C style array, essentially you can do the same thing using standard array also. I'm just using the C style array for now. Now, let's say I write something like this. Oh, okay. So what this thing means is I can store 10. So because the size is 10, I can store 10 of what? Of this data type, which is integer. So I have asked for 10 integer storage in a stack. This is stack allocated, but the idea also extends to vectors, which is heap allocated. The A here you see is actually a pointer. Okay. So when I say a pointer, the pointer is essentially what a variable. Okay. Here A is a variable, right? It stores an address. So now let's say when I say there is a size 10, which is a contiguous chunk of memory, they actually occupy some memory somewhere on like RAM, right? Now the starting address is what is that address is stored inside A. Here when I write star A, I'm dereferencing that position as in accessing that value and storing 7 to it. Okay, you can actually um, see each of them. So before maybe printing, okay, let's do it this way also. Hope this doesn't go anywhere. Okay, fine. Let's see. Great. So what I did here is I just printed the value of A. Okay. Now, important thing here is A is actually a pointer. It's what the val you can think of A as like a some variable like similar to what we used here. A or we use sizes. Okay. Actually, you can think of like size itself. So size is some variable of type integer. Okay. Stores value 10. Awesome. Now A is also a variable of what type? So its type is actually size underscore t. Okay. Now size underscore t is essentially a way of saying the maximum integer that can be represented in any computer. Okay. Now for me, for let's say in our case here, integer is 4 bytes and which is 32 bits. So and this is a 64-bit system. So size t will be a 64-bit integer unsigned. Okay. So and then now why is that? That's because when you try to represent an address, okay, you represent them using numbers, like integers actually. Now, the maximum that you can represent in your system will correspond to what you can represent in a as an address itself, right? The same thing is what A is, and it stores an address. And if you see here, it is actually represented in a hexa decimal format. But you can be rest assured, if you convert it into decimals or something, it will look like a large number. Now, the point here I'm trying to make is pointers themselves just store addresses. Okay. And address is some memory position in RAM. Now, we access them using dereference operators and just shift them. That's it. Pointers themselves. Okay. Maybe I'll just write it. Type of A is address of is the essential address. Okay. It can be 32 or 64 bytes or bits. Now, but important thing, type of pointer array, it is some kind of inbuilt variable like integer or double or float, anything, whatever, or it can be actually some custom data type of. Okay. Now, here I've made it as an integer, but it need not be. I can actually make it as a double also. It's absolutely okay. Now, 7 here it's an integer. You can think of it like it's 7.0 or something. That's what I'm storing here. And um, an address with size underscore. Okay. Now, uh, I hope this is a bit clear. So the pointer itself has a data type, which is size underscore t, which is like you can think of it like unsigned long integer or something. Essentially, it's a way of representing the address because it has to store addresses, right? Pointer is a variable which stores addresses, and the addresses themselves can be quite huge, and that's what we're seeing here. It's written in hexadecimal, but you can think of it like if it was represented in binary or let's say in decimal, it'll be large number, but an integer nonetheless. Now, the important thing here is the value that the pointer is like actually storing. So this is an address, sure, like what we're seeing here, but the values that it stores, they can be of some data types. So it can like inbuilt or custom or something. It could be integer, it could be double, it could be float, and so on. Okay. Now, that is important because it has to have contiguous um, contiguity, and defining the data type allows it to access with correct shifts. Okay. Now, one other thing one can do is maybe just write some loops. Here, I equals to 0, I less than input size, I plus plus. Okay. Maybe fill this with I. Okay. And if you can put something like a conditional. So let's say the value is not divisible by 1. Okay. As in by divisible by 2. So it has a remainder 1. So this is the remainder operator. Okay. Then we'll try to print that same value. Let's print it. Oh yeah, double integer. Yeah, my bad. Let's keep it integer for now. Okay, awesome. So they printed the actual address of A, and then the values that it has. Okay. Just write it as address. Yeah. So the address of it, and then all those values which are not divisible by 2 are printed. Okay. So the essentially this bracket operation that we saw is the dereference operator. Okay. If you can write the same thing this way also. So here A is the pointer, right? I can add numbers to it to correctly mark how much shift unit of shifts I need to have, and that unit is already determined by the data type. Okay, so this is the shift, and then dereferencing it will let me access that value itself. When I say dereference, it actually means accessing that pointer. Okay, the value that it has. Same thing, you can just do it this way also. So as you can see, you get the same result itself. I should comment this. Yes. So you get the same result itself. So essentially, doing it this way or this way is essentially the same. Okay. Okay. Good. Any questions so far? Okay. If no questions, then we can move on. So the next thing that we can maybe try to see is 2D arrays. Okay. So similar to how we saw here that we can have like a array, okay, with a single variable, as in this is a one-dimensional array. You can have multiple dimensional arrays, and let's take a look at some of them. Okay, we'll use vectors and C-star arrays. Okay, then write the main functions. So I'll define an array, okay, A, which is like 5, B, another array B, which is let's say 7, and another array C, which is let's say 2, 7, and 10. Now, oh, there's a question. Concept of vectors. Sure. Okay. Yeah, sure. Um, so let's take a look at 2D arrays first. Then I'll repeat about vectors again. Okay. Right. So the idea behind 2D arrays is also similar to 1D array. Okay. It's essentially a list of contiguous data that you're trying to access. Okay. So now let's say, but the only difference is that you can think of like a matrix. So a single array here was just a one-dimensional thing, but a 2D array with two in brackets here represents like a matrix, 5 by 3 matrix or something like that. Okay. Here B is one-dimensional and C is three-dimensional. You can have an n-dimensional array. That's absolutely okay. So I'll give the value I. I runs from the first for the first index, okay, and then I plus plus. Then let's make J run till 3 with J plus plus. Okay. Then A access these values A and J, and maybe just fill it according to this rule. What I did here is, sorry, yeah. What I did here is, I'm filling these values according to some index. So first I'm putting it as J plus I times the size of J. Here it could be actually anything, but what I'm trying to do here is making sort of a contiguous data. So let's say I do this out. Let's say let me just print the output. I think that will make this clear. So um, or let's have the same loops actually. Maybe I just copy this. Okay, and let's have STDC outs. Solid value of it, and then just parse this 2D vector. Okay, let's compile and print this. Awesome. So if you see here, what I'm trying to do is input, like fill the 2D array with some values and then try to print that. Okay. Now the uh, reason behind choosing this kind of structure is if I try to access, so the way for loops occur is the um, first for loop here, the one which is the most deep, that gets run first, then the next loop, and then next loop above, and so on. Okay, that's how the order of execution happens. Now, because I index J first, okay, and then I, so J is sort of, you can think of there's another way of saying this. J is the fastest index. Then the next fastest is I, and so on. In 2D arrays, okay, the rightmost one is actually the fastest because this is C. C has this convention that the rightmost index is the fastest. So I chose this sort of expression where J is the fastest, and then you see the next fastest multiplied with some value. So J loops over first to fill the values for for a given I, and then the I increments, okay, in this loop, and then so on. So with this, what happens is if when you try to print these values to the arrays, it actually goes in order, and all of them are in sequential order. Okay. I hope this makes the layout of 2D array clear. Essentially, in memory, even 2D arrays are flattened, like stored in a flattened 1D array, because memory wise, it's essentially the same way if you look at it. Okay, so let's take example of vector itself. So what I'm trying to get at is vectors, you can represent the same thing in a form of a vector also. Okay, let's say D, and we know the size. So it's 5 times 3, so it's 15. I'll just declare this vector. Okay, and plus then read out size. I plus plus. Now I'll try to fill these values, okay, with just I. And essentially, if you think carefully, this code and this code is essentially doing the same thing. I'm filling the values from 0 to size or 15 in a flattened 1D array. It just so happens that here it is a 5 cross 3 matrix, which in itself is actually stored in a flattened array. I'm just using a vector to do the same thing. Okay, so let's print the use the loop here, and yeah, I think that should be good to go. Yeah, let's change the values. Awesome. As you see, the values of a that we see that is stored is from 0 to 15, 0 to 14 actually. 15 values, 0 to 14. Same thing happens for D also. So 0 to 14. What I'm trying to drive here is you can use a 2D array or you can use a vector. They the layout wise, they're essentially the same thing. You can actually just flatten the whole thing, or if you find it more convenient, you can have n-dimensional arrays, but you can achieve the same thing by using a flattened vector itself. Okay. Now, very important thing to note, this is C-style array, so these are stack allocated. I'm using a vector here, so this is heap allocated. You can essentially do the same thing with an array and flatten the whole thing. Okay. Do not get confused. So this is still a slight thing to keep in mind. You can essentially use a array here, no problem. Maybe I'll just do that. But the important thing is you have to give a size here. Okay, rest of the code should be fine. Yeah. Now the array here is also stack allocated. The ABC are already also stack allocated, but they're C style arrays. Here the D is from C++ STL library. Okay. Any questions so far? I hope this is clear. Okay. Okay. Right. Moving on then. Let's learn about const qualifier true. So um right. First we'll start with as usual, including the IOStree header file. So let's have the main function first. I have an integer n, which is let's say 5. Then a pointer, okay, n, which has value 0. So essentially it's a pointer. Um, Here, one thing to note is the pointer just stores first value. I haven't allocated or anything, so it just stores one single value, which is 0. But nonetheless, it's a pointer. It's not just a simple variable, it's a pointer. Now let's say I do this. Mm, yeah. Okay. So then that let's try to print the value of n. Can anybody tell what should be the value of n if I want to access the value of n? So if I wanted to access the value of n, what should I put here? Anybody? I would have put actually m. m itself because this is a variable. So I can just to have print m. I don't need to do any other changes. But to access the value of n, I have to dereference the pointer n and just access it. Okay. Yes, that's that. Not star m. Yeah, we'll just put m because it's m is just a variable. So you just put m. But if it was n, which is a pointer, you have to put star n. Okay. Now let's compile and run this. Awesome. So, okay, let me remove this thing first and then I'll come to it. Set fault. Oh yeah. So this happens because I actually did not allocate anything. That's fine. Let's just declare it for now and then use this. So what I'm trying to get at here is m is a variable which has the value 5. Now n is a pointer. That's fine. But what I'm doing in in this next line is I'm I'm setting n equal to something. And what is this something? Now there's an ampersand of m. What this part of the code actually means is ampersand is the address. So m is the variable and in memory it has some address. Okay. Now the address that m has is you can access it by doing like using an ampersand. Okay. That ampersand when operated on m gives me the address of n. That's exactly what I'm storing in n. Remember in pointers, okay, like this is the way a pointer is declared, but the variable n itself just stores addresses. So this is a very valid way of writing code where you are storing addresses of your address of m inside n. Okay. Now because n is now pointing to m, okay, if I try to compile and run, both of them point to the same value 5. Let's say I change it to 7. What do you guys think will happen if I compile and run? Let's print and see. Both of them have the value 7. That's because m anyway we knew will print 7 because that's what it is stored. But since I declare a pointer n and set its address, so n now stores has the address of m itself. It will always, when dereferenced like this, will always print the same value as whatever m is. Okay. So now I hope this part was clear with some example, like how pointers and addresses, ampersand thing works. Let's declare another variable. Okay. Now this is something called a global scope. Okay. Let's put it 10 here. Okay. Yeah. Now this variable p is constant and integer, has the value 7. So essentially this won't change as that is the motivation behind using const. Okay. Now maybe scope I'll come later. So let's learn about the const itself. So now what you can do is also point to the address of P. Okay. Let's try to print. Oh, yeah, that's fine. That should be okay. Can anybody tell me what will be the output of M and N? Or basically the output of this program? You can feel free to unmute and tell the answers if you want. Yeah, so there's an answer 10, 7, M equals to 10. Okay. Let's check the code. Now, here's an important thing. const qualifiers, yes. Let's make it not constant for now. Okay, 10 and 7. As said by some people, that's correct. So m is set to 10. So that's what we are getting here. Yes, that's correct. And n now has been set to the address of p. Not and I mean we set it to m before, but then we can reset it to the address of p. Okay. And now it will point to the uh, variable p. Okay. So and whatever p was set to is something what it will only print. Okay. So the value of m is 10, value of n is 7 because p is 7. Is correct. And now let's say let's look at that error that we got before. A constant, let's say I put, I'll get a compilation error. The reason for that is we're assigning an integer pointer, which is this an integer pointer from a const integer pointer. Okay, so the address of p is actually const. So we'll learn about constness and other things maybe later on. But essentially, one can think like because the variable cannot be changed. Okay, yeah, maybe I can tell it now itself. Because the variable p cannot be changed, when you try to assign its address to some kind of integer which is not itself const qualified, so that actually means that your this n later can change its value. So you can probably do something like n pointer equals to um, 8 or 9. So this should not be allowed if p is const qualified because you should not be able to change the value of p. Let's do this way and maybe try to print p. Okay. So as you can see, because the address of p is stored in n, I can dereference n, okay, and set the value to 9. So what this does is it goes to the address that is stored in n, which is the actual the value p, and set it to 9. Okay, so it's an indirect way of changing the variable p, okay, in a roundabout way. But I hope the concept is clear, like how you can manipulate with pointers. Okay. Again, doesn't need to go this roundabout way to just change the value of p, but this should give you an idea about the concepts behind addresses, pointers, and so on and so forth. Okay. Uh, Now let's look at this value. We'll ignore changing things like this. Okay, that should be fine. Let's see this. Yeah, I hope this should compile. Okay, awesome. So again, it changes values and things appropriately, as you can check. So m was set to 10, and now we set the address to n and then change it to 9. So now m is also 9, n is also 9 because that's what the address has. P was left unchanged, so it is 7. Okay. Now, this is one way of declaring something which doesn't change throughout the code. Sort of an equivalent thing in C used to be pragma, as defined P as 7. Now, this is a very different thing. So if you see here, these hash things are actually macros. Okay. Now each macro has its own definition and so on. What hash include does is it searches for this file, okay, IO string, and this copies the whole content of it and pastes at the line 1 while compilation. Okay. What hash define does is it searches for p, okay, any instance of p it can find in the later part of the code and just replaces that with whatever value you give here or whatever text or something. I would say actually more accurately would be text because these hash defines and hash pragmas, these are macros. More accurate to say them are they are pre-processors. Okay, they are even before the compilation of your code starts, these preprocessors are evaluated. Okay. After they are done, then only the code comparison starts. So very important, before your code even gets compiled, if you have macros like this, hash define P7, let's say, it'll literally go and search for the letter P here. So it finds it here. I think it should ignore the, since this is a comment, it should ignore this. It will find P here and replace the value 7 there. Okay. Now let's comment this itself. So the reason to show you this is essentially you can have P defined to be 7, okay, in your code. But, and this is the C way of writing something, let's say a constant or something. But again, no, I wouldn't say C way. You can even use macros in C++. But there's a huge difference between writing a const integer P7 and hash defined P7. Okay. Here there is an actual variable P which is stored like containing value 7. But if you use macros like hash defines, they don't not even stored. Like this P is not stored anywhere. It just goes through the code, sees, finds whatever thing you define here. It need not be P. It can be like something like threads, let's say, or any other code that you have. So my code or something would be there. Some kind of keyword. So it searches for this text and replaces it with whatever you have defined here, like 7 or something. Now, macros need to be carefully used because, as you can see, because these are predefined preprocessors, before your code even gets executed, they can change your code massively, and then your compilation starts. So these are very difficult to even debug because compilation errors you actually get after it gets compiled, right? So, and this has let's look at some like try printing each other and see what each what each of them mean. So M being 9, I guess you can understand why. N also, and P being 7 is because we just defined it. That's okay. But let's comment that and then use a macro. If you see here, P also is printed to be 7 because P here is the only place that it is defined. Okay, and it replaces 7. I can replace to be 8, and it will essentially just remove this, scratch this code and replace 8 here. Okay, as you can see. So again, the key takeaway is that this is a macro. While it behaves very similar to a const, it's not actually the same thing. Okay, here it's P is a variable, but here P is just it's not a variable. It's more of a um, text that needs to be replaced with whatever value that we give. Okay, so that's what a hash define is. It defines a string like this to be 8. So one must be very careful while using hash defines. Okay. Right. Now, okay, since we saw this is a question, sure. Okay. Um, as we saw vectors, maybe since somebody asked about vectors to explain, and I'm going to uh, explain about this is the C++ way of using vectors. I was going to say start with the C way to give you a contrast. Maybe this is a good time to um, talk about like what a vector is again. So a vector is essentially a collection of some data type, usually an inbuilt data type, and by that I mean integers, doubles, floats, something like that. Okay. Now these kind of data types, okay, uh, determine how much your computer or your program will have that have some memory allocated. So by default, integers have um sorry, yeah. By default, integers have in usual I reported architectures to have like 4 bytes. Okay, then doubles or even float also. Doubles, so integer has 4, float has also 4 bytes. The longer width for each of them is long int. You can use long int for okay 2D vector operations. Yeah, I can show an example of 2D vectors also. Sure. Let me come to that in the next after this then. So you have the equivalent of the 64-bit equivalent of the same thing. For integer, it will be long integer, so it will be 64 bits. The equivalent of float, where the float was 4 bytes, is a double, which is 8 bytes. Okay. Now, what does a vector actually do? A vector actually has a certain size. Here, it's determined by 15 or something. Now, it's essentially a collection of integers, whatever inbuilt data type we give. So the memory that A occupies will be 15 times 4 bytes. Okay. You can think of that like the actual memory that is I as a programmer I will use for my storing values and so on. And this abstract idea of having a collection of data continuously is actually a list. STL, the standard template library, gives us a useful class called vector to represent this list. Again, if you have an array, this is also a list. The difference between the vector and array is that this is stack allocated, this is heap allocated. Heap allocation means it is on the RAM where the memory pool is larger. You can access more data, like request also for more data. But the downside is accessing it will be slower than stack because stack is allocated in cache. Okay. The downside then with cache is you don't have a very large pool because cache is limited, right? Okay. I hope the explanation for vector is clear. I'll repeat with how do we maybe do uh, vector storage in C++ and but without the vector class. Okay, let's use the new this time. Okay, so let's define a pointer. Okay. Now main. I'll use a new keyword. So this way of writing new is essentially what I'm trying to get at. So okay. So what I'm doing here is I'm declaring integer of 5. Okay, just like it will have 5 values, but there is this new keyword which will allocate that memory, not like a stack allocation. So integer 5 usually is a stack allocated array, right? But this array now gets allocated in heap. So this new keyword is essentially what helps doing that. And the pointer that it returns, essentially, we want to know where it has allocated. I'm storing it in A. Then you can do the usual operations on this. Like let's say I define I store values and then plus plus the this time I'll just store something like this. Okay. Then let's print the values. Right. Then the value of at that position. Okay.
Excuse me, sir.
Yeah.
Can I, sir, is it
Mm.
essential to write new whenever we are creating some array or so like this, or it is optional?
Mm. It is optional. Here I'm trying to actually showcase an example where um, so integer 5 is a, if you see
Right.
this example, yeah. So if I declare integer a of 10 or something, this is actually a C style array. Okay.
Sorry, which array?
C style. So when I say C style, as in
Okay,
the
okay, okay,
program,
okay,
yeah,
okay.
yeah,
Yes.
in the programming language C, you declare arrays as such. Like you put the declaration, the data type, the variable a, and then with the bracket you specify what is the size of that array. Okay.
Okay.
Now,
Okay.
same thing was done using the C++ way, using standard array. It's essentially the same thing, but there is a difference of the syntax. Okay. Now, when I write something with new, okay, it makes sure that whatever you're declaring is actually heap allocated. So that's what I'm trying to get at here. So it essentially declares 5 integers, okay? And now we can access them values also. That is absolutely fine, as you can see here. But the reason to declare and do all this is just to showcase you the example of new. You absolutely not, I would say absolutely. In most, if you're just using vectors and arrays, okay, if you just need a list class with a storage and all, and if this suffices your work, then absolutely you don't need to use this new keyword itself ever. But sometimes you have to declare um, some objects and classes, and then you have to have, instead of passing that object itself, you pass a pointer of that object. So yeah, what I mean to say is sometimes you actually need to use them. So hence I'm just giving you an example to just get yourself familiar. But in a lot of the cases, you can just get away with uh, a like declare a vector like this, resize it, and then fill the values and access them and so on. Yeah, it's not necessary to use new to have a heap allocation like what I'm doing here. You can absolutely do just declare a standard vector and let it take care of all the heap allocation. But this is something to just be familiar with. That's all. Yeah. I hope that answers the question.
Yes, sir.
Yeah,
Thank you.
sure. The important thing with um, vectors is it takes care of allocation, and a very important thing is deallocation also. So as soon as, okay, this might be a good time to talk about scope. So if you see this variable a, okay, it should be bounded by two curly braces. Okay, any code, if it is bounded by two braces, that is the scope of that variable. So if I take this guy, this a, it is bounded by these two parentheses, right? Now the scope, when I so this is the concept for of scope. The scope of a is between here and here. So essentially, a does not exist as in after this scope. The nice thing about this idea behind scope is as soon as a gets out of scope, as in when your code reaches this position of bracket, its destructor gets called. We'll learn about this constructor and destructor, but essentially this is the way of deallocating whatever variable was declared inside that scope. So for size, it is true for size also. It's not just for a, for size also. It gets deallocated as soon as the program reaches this position, line 28. Okay. The good thing about having this concept of scope is you can have some automations, like classes will take care of, like here in this case, of classes themselves will take care of allocation and deallocation. Okay. But if you use new, you have to manually delete this quarter. Okay. So this is what I was trying to get at. Class, the vector class itself makes it very easy to deal with such things. Otherwise, one has to do sometimes a roundabout way of doing things. Nonetheless, this is also a valid way of writing the same code. Okay. Yeah. Okay. For completion, maybe I'll just write the same code. Uh, maybe just write on the line. I'm essentially writing the same thing, but using the vector class. Okay. Let's start the code. Again, I would encourage you to participate, as in if you have questions, you can feel free to interrupt anytime. That's absolutely okay. If you don't understand any code or point, yes. Oh. So there was a question about 2D vector operation. Sure. Essentially, if you see this code, um, yeah. Okay, let's make since I'm making a heap vector itself, might as well add the 2D vector itself. Sure. So standard vector A of size x, or not x. Let's just leave it for now. We'll resize it later. So standard CO. Okay, I can add some other things here. So let's print the size of it. Any guesses what if I try to print the size of A, what will it show? Anyone? Yes, that's an answer 0. Yes, that's correct. Because when I declare the standard vector A, sorry about the syntax. So standard vector A, I have not declared size or anything actually. So I'm not given it in a bracket or resized or anything. So if I try to print this guy, oh, I don't think I printed this new also. But let me do that. Oh, sorry, my bad. This is in a different file. But that should be fine. Okay, let's see the output for this. So the 3 times I, essentially like for the corresponding I am just making it 3 times. So I hope this is clear. It is heap allocated, but you can work with the same way using the bracket operations, store values, print values, and so on. Okay. Now let's look at the heap allocation with vectors now. Size is 0, as someone mentioned in the chat, because we have not resized it or we have not declared how much the value, what will be the size of A initially. Okay, so its size is 0. Now let's say I resize it to 5 and then print the same thing. I hope uh, people are clear with what will be the output for this. it was 0 here, okay, and its size is reset to resized to 5. So the now the current size is 5. Okay. Again, for completeness sake, I'll just copy this. You can think of it like this. Essentially, no difference in the code now. Even if you declare it in a new using the new for heap allocation or using the vector itself. So this is just to complete it. Let's print it. Yeah, the code is essentially the same. Okay. Now there's a question about 2D array manipulation, like 2D vectors, right? So what one can do is declare standard vector, and then you have to have templates, right? So you are giving a um, inbuilt data type like int and so on. What one can do is actually give the same whole thing inside the template. Okay, and then declare not A maybe, but B. So now what I'm doing here is I'm declaring B, which not think of A first. What it used to mean is there is a class where it stored integers. Now I have B, which stores standard vectors, and they themselves are integers. So this is a 2D representation. So the 2D array that we see of 5 times 3 and so on, you can sort of write a similar thing in using vectors also. Okay. So instead of just having a flattened array like we did here.
Excuse me, sir.
Yeah.
Excuse-
Yeah.
Sir, you declared C vector as three-dimensional because three.
Yeah. Yeah.
So it is three-dimensional. Okay.
Yes. Yeah.
Okay. Okay. Okay.
Right. You can choose to have n-dimensional array. I would say this more accurately, this is an array actually. So you can have any n dimension. Here it is 2. Or maybe I'll just write it. The array. Say 1D array, which is your normal arrays that one encounters. This is a 3D array. In general, you can have any ND arrays. Yes. Given your sizes are not too large that you get stack overflow issues, but assuming we are within reasonable regime of data, you should be able to declare any ND array essentially. Slight thing again to just remember back of mind. It's important to note when you declare C-style arrays like this or using standard array or anything, the size that you give becomes very important because it's possible that you might give like 10 instead of 15, maybe let's say 1 billion or 1 trillion. Your cache may not be enough to store all that values. Okay. So you usually get a stack overflow error. If you have if you use C-style arrays, standard arrays should probably have some error handling to tell you that no, you can't do this or something. Okay. Another advantage of using uh, STL classes like arrays, they take care of error handling also. Okay. Again, similarly for vectors also, if you try to resize or declare some kind of vector with instead of 5 here, maybe a huge number which your RAM or your OS or the operating system cannot provide, then it will throw an error. Okay. And that error handling itself is like defined inside the class. So you don't have to worry about it. Again, another use of using this STL standard vectors and standard arrays. Okay. Now coming back to B. B is what we declare as 2D vector. So standard vector of standard vectors. Okay. So how does one even go about working with this? So you can do it like this, where I'll parse First, I'll resize B itself. Okay. So maybe let's say, let's take this example itself. So here it's 5 cross 3, right? So outermost is 5 and innermost is 3, as in the fastest index is 3. For if you think about the loop itself, the lowest most for loop is 3, has 3 as the size, and 5 for the outermost. Here, sorry, here the outermost will be 5. We'll put it here and then go through each size, go through each of the access each of the vector, okay, size, then I plus plus integer I less than this dot size, which is 5 here, okay, and then I'll resize each of them to be 3, but not B. I won't resize B. I resize B I. Okay, so I'll go through the code again. Essentially, what I'm doing is I declared a standard vector of standard vector integer B. Okay, I resize B to be 5. So this structure itself has 5 units, and each unit is actually a standard vector, which have not been allocated. Each of this smaller unit I can access by B of I. Now, important thing, very important, B of I itself is a vector, is a standard vector of integer. So I can resize each of them to what? Now 3. So 3 is the integers that B of i's will store, and as a whole, B is of size 5. So I hope this idea is sort of clear. Um, Essentially, it is a 5 cross 3 2D vector, what you represent as a array, okay? But I'm representing using a vector now. You can actually do uh, instead of vectors arrays to think like this is, since this is an array and stack allocated, I want stack allocation here also. You can do that. But what I trying to get at is this is quite common because these are 2D matrices. You can represent 2D matrices as a standard vector also. So this is a valid code. Okay. I won't go into, okay, maybe I'll mention a slight thing about performance. If you have flattened vectors like this, these are much more efficient, okay, to access because this is actually contiguous data of 15 values. And if you know those, the sizes and all, like, even if you actually think about it, if you don't know the size also, you can use just declare, maybe not this one. Oh yeah, actually this one only. Anyway, think of this standard as vectors now. So a list with known sizes, accessing them is much faster for a computer than having something like this, where now the problem is it's a standard vector, yes, and each of the storage is a standard vector, but they will be uh, scattered around. Sort of, you can think of this one as like a linked list. So while that list was something of a data structure where all the values were contiguous, you can represent the same thing in a linked list. But again, from if you care about this aspect of performance, linked list here it will be a little slower because then you have then um, the program has to jump from accessing each bi. So b0 could be in one location, b0 b1 could be in another location. It will access b0 3 values, let's say. Okay, maybe I'll just print the thing so that it is a little more clearer. P dot size vector. The reason to write B size on not 5 and 3 is because I can actually abstract them. I can put some variables here and then rest of the code still won't change. So that's the only reason. Um, Maybe I'll mention it this way. Here m equals to 5, n equals to 3, put n here, n here. Now here will be I, here will be J. Okay. As you can see, the dereference is essentially looks like how we access even the 2D arrays, right? We use double brackets, right? For standard like 2D vectors also, the dereferences or the accessing the value looks essentially the same. Okay. Now, if I put the values, let's say, well, let's put the same, and then print the whole thing. Yeah. Let's print it, and then I'll repeat the explanation again. Okay. So if you see the oh, I have A also here. Okay. Let's comment that for now. Okay. Yeah, as expected, you can see the output is from 0 to 14. Okay. Essentially, what we did here with standard array, or we can use a standard vector also. Whatever we did as a flattened array, okay, you can do the same thing in a 2D vector also representation, right? Now, important thing here is to note is that I still had to use two loops. One is because I have to loop over the standard vector itself, right? That was the b dot size, right? And then the second loop is for the second standard vector, okay, which is b of I. So each element of b is itself a vector. So I'm accessing that vector size. So that is the bi. Okay. And I'm putting those values as such, okay, so on and so forth, where j is the index of the innermost vector, and then the outer vector I, and so on. Similarly, I have to do a resize also because each of the PIs were not allocated any memory. So if you try to access them without resizing, you'll get set faults. Okay, you can't just resize B and expect inner values to be also be allocated. That does not happen because you have only resized a standard vector saying, let's say M is 5 here, right? So saying I need a standard vector where where it stores 5 standard vectors. Okay. Now thing is the inside the um, smaller uh, standard vector is still not allocated any memory. So that's hence this second loop where I say if b dot size is 5, so it will have some 5 values, right? Then resize of that will tell each each of these standard vectors will now store n as in 3 values. Okay, I access them using b of ij, which is j plus i3. I just store those values, and again I can access printing them using just bij. Okay.
Excuse me, sir. Why
Yeah.
you
Well,
write b I j is equal to j plus I star 3? What is
oh,
its meaning?
what is meaning? Okay, maybe I should write it as b times I dot b size. That is actually more clearer. So if you think about it, um, here I'm trying to make a standard vector b, which is a 2D matrix. Okay, you can think like a matrix where one dimension of it is 5 and another dimension is 3. Okay. So because of that, I want my fastest dimension to go through first n. So that is the index j. That is indexing this index j. Okay. Now j plus, if you do if you think about it actually, if I think of my 2D array as a linear flattened array and try to index them. Okay. So the first, so it's a row major order. So imagine a matrix with 5 rows, 3 columns. Okay. I will fill the first entry 0, 0 as 0, then the right one, which is first row, second column with the value 1. Then the next entry will be the first row, third column, which is the value 2. Then the next entry will be second row, first column. Then the next entry will be second row, second column, and so on. So if this is the way I want to store values, and if you see there is a particular order in which I'm storing these values, okay, this ordering where I'm going row by row is actually called row major order of accessing a matrix. And in
Okay.
C or
Okay.
in in C or in C++, we follow row major order. Okay. Now
Okay.
that yes. Now there the index j, which is at the rightmost, that index goes over every column. Okay. Hence, I first put the j as the fastest index as in j. Then for the second one, I give the size of j, as in p dot size is actually the size of j, as in uh, you can think of it like this. Actually, is n also. Yeah, but that's okay. You can think of it like n. Okay. So now sorry, my bad. Here it is not b dot size. It will be n itself. Yeah, it will be since b of each of b of I dot size is same for all of them, which is n. Let me just put n here so that things are clear. Yeah. If you think about it, here there are 3 columns. So if I'm indexing uh, the row major order in a oh, yeah, yeah, you'll get recordings. I'll upload the recordings, whatever you discussed. Yes, yeah. So there should be a YouTube playlist. You should be able to access all of the week's lectures in that. I'll also upload all the codes that I discuss, and yeah, you can access them also. Yeah. So what I was saying is, so the this index itself. So first you write j, and then I.
Sir, another thing
Mhm.
is that
Yeah.
we can't use namespace using namespace because every time you are using the standard and then scope resolution operators.
So thing is, you can use using standard namespace standard.
Mm.
It's just that uh, in practice, in like production codes and such, it's more it's just a better practice to give the full namespace to avoid collisions. In certain regions of the code, you can definitely use it. You can have scopes and all, like I was discussing these brackets, but usually readability takes priority. So because they need, large codes need to be maintained, and someone else who comes up needs to recognize what's actually happening. Usually it is good practice to have the full namespace. Yes, it makes the code much larger and longer, but it's a trade-off for readability. Again, it depends on how a code is maintained. You can absolutely use. There's nothing wrong with using a namespace standard.
Okay.
It's just that things are more clearer when, at least when I see standard than namespace vector. So I know that this vector class comes from the STL, standard template library standard. Okay, so that's the thing. Now you can access the same B using this bij operator, and then only difference is that we are treating this B as a standard vector of standard vectors. Okay, the standard vector here, sorry, the 2D array here was an array, a C-style array. We just made the same, like do it the same way, but using vectors. You can use arrays also, but I'm just using vectors here. Okay, right. So it prints the values. Okay. So if you had, let's say, a longer stand vector, you can actually play around, like something like this, where so it's a three-dimensional array, and so on. You can have n-dimensional linked list. I mean, it's kind of a linked list, but well, anyway. Uh, so yeah, so I was saying about performance. Yes. So thing about this allocation is, so there is a memory where B is stored. Yes, but each of these BIs, uh, the allocation that happens for each of the BIs, it can be scattered around. So when you try to access these values and print, it can be much slower than just declaring a single specific size array. Okay, that's something to keep in mind from performance perspective, but it's not essential. I mean, it's not essential to just to keep in mind. It's not very important, I would say, as in unless you worry about performance, but just to understand. Yeah, you can have more and more layers here. Like this is a three-dimensional array now. Okay, now yeah, here another important thing is it's not a doubly linked list. It's just a single linked list, single direction. Yeah, and so what here will happen is you can have like C, I, J, let's say here it is K, another loop for it. Maybe I'll write it here. Uh, okay. Yeah, I think that should be fine. So essentially, there is a pattern to how these uh, indices and loops change. So it's I, B size I, J with BI size and J plus plus. So B is fine, J is fine here. Yes. K will have IJ, okay, and K. Here, the extra thing that changes is K, okay, plus. Then J will be multiplied with the size of K, okay. Always remember when you try to index something like this, it's easier to go from smallest, like the fastest index to the largest. So the order will be K, J, I, right? K, J, and I. And then you have to multiply with something, right? So that something is usually, it's easy to remember. So you multiply K, then plus J, J times the size of K, which is that. Uh, oh, my bad, sorry, it should be K. I, J, K, I, J, K, I, J, K, yes. Size of J is till this. So you can multiply here. Here, because all of them are the same size, here there should be resize also, but assume they're all the same sizes. Okay. So you just multiply size plus I times then the size of J times size of this guy times size of J. Size of J is this. This is a useful way of indexing um, flattened indices for any, let's say, a tensor with IJK, okay, where there is an ordering for J, K, J, and I. So if you deal with high dimensional tensors, this is a neat way of remembering how to index each of them. So you start with the fastest index, then the next, and then the next. So here, let me highlight K, J, and I, and then multiply appropriately each of them with some values. How to determine them? Now, J, when you multiply with the size of K, then plus I, right? You multiply with the size of the maximum size of J, okay? And whatever this size is, like this size including, right? Just copy that and then the size of J. Okay. Yes. Let me just comment it. Yeah. This will give you errors because I have not resized any of them. So maybe you can try while trying this code out, you can resize them appropriately and then try to fill this class. Okay. You can specify M and maybe not K. Let me use P maybe as 5. Oh, no. Uh, 5, 3, maybe 2. Yeah. So anything else which is used? Yeah, no. Those are next, but probably not required anymore. Okay. So that P index can be, yeah, like you can think of like an exercise to index maybe the third dimension of C. So this will be a 3D array, a 3D list, you can think like, but using vectors now. So yeah. Okay. Any questions so far? So this was for the 2D operation, vector operations that was asked in the chat. Then okay, I can maybe
Sir,
yeah,
the last line, that
yeah.
means CIJK, the
Mhm.
last one will be plus now, or it will be again star. The last one,
This one,
BI into size J. That before of that it must be plus now.
this line, this one,
Now this one, next one.
this one.
Huh.
It will be star because
Again.
yeah. So because k is the index, j is the index, then I have to multiply with something. Okay, don't get confused with this huge size. Let me just tell represent it by something like not a function, but like think of it like some size. Okay, s of k. When I say that, what I mean is uh, you have k, you have j, you have I, and here the whole thing is the size of what I am to multiply with. Okay, so s of j is some size. So by that I mean some size of maximum index of j, some size of maximum index of k. So here again k will also be required. You can
Okay.
actually work it out. Think of like a 3D cube, okay, and then try to place values like each direction x, y, z, and you'll see that as you go around one plane. So let's say you have during x direction you completed, then you move in y direction, but in a z equal to 0 plane or something, and then fill all the values. You'll start seeing a pattern actually. Then
Okay.
when you move the next plane above, once you're done with one plane. So essentially, the neat trick to remember this is k is the fastest index, then j, then I, and so on. You just write all the indices. Then you have to multiply each of them with some factor. That factor is
Okay, sir.
determined by, yeah, the factor is
Okay.
determined by j times size of k plus I times size of the whole term in the left hand side. So it will be size of j times size of k. Okay. For completeness, I'll just leave it here like this. Yeah.
Sir, could you leave that also, like, and the complete also.
Yeah, this one, right? I just left it. Yeah, yeah, this one.
This
Yeah.
one and the thing you used to make us understand. That one also, could you leave that
Oh,
in the
okay.
comments?
Sure, sure, sure. Sure. Just writing here you can think s as a size of function. Okay.
Okay.
Don't get confused. This is like um, just some notation I'm using just to represent this whatever you have to multiply. Okay. And this is k plus j star k plus I times s star j and k. Yeah. Okay, that's fine. Okay, neat. I hope this part is clear. This is essentially how you represent n-dimensional uh, array or list or whatever you want to think of, but in using vectors. Okay. So essentially the uh, bracket operator like this won't change. For C, it will be I, J, K, and so on. For n-dimensional vector, it will be higher and higher brackets. Like we'll have more and more indices. That's all. Essentially, the idea is the same. Okay. Now, next thing we can maybe Two is references, and okay, that might take some time. That's okay. Mm, let's do scope. Yes. So I have integer name. Mm, as usual, uh, main function that always we need to have. And let's say I determine x 10. Okay, then let's do it this way. Okay. Now, this is a simple code where I declare x, store it as 10, and then try to print it. I guess people can guess what will be the output when I print this. So this will be this file scope. Yeah, the value is 10. Yeah, I think no surprises there. Okay, but what if I change the code to something like this? Okay, now what do you think will happen? So I'm declaring x here, and again declaring and setting it here, and then printing it. Any guesses what will be the output? Okay, so chat
10
says
होना चाहिए ना?
Will it
10,
still be 10?
will be 10. Okay, let's see. That's correct. Now, here, important thing comes into play is about scope is the name of the variable can be the same, as in you can have x in, so this is outside main, so it's sort of like a global scope, right? Here, the x which is determined, like declared inside this scope, the brackets, is the local variable. So this variable, right, is local, like a newly created, also called as x, yes. But while we access this x here without explicitly saying or anything, the local variable gets accessed. Okay. So the need, another way to look at it is do the same thing. Okay. But here to make it more clear, I'll call it local x. I'll call it global x. Okay. But can anybody tell me how to access this global variable x? If I just put x, it will be accessing this line 6 variable x, which is local to it. Okay. But if I want to access this global variable x, then what do I do here?
So scope resolution operator we have to use.
Yes. So we just do it this way. So there is no namespace as such, as in no name given. So there is nothing required. But if you just give it the double colon, it is you can use that to access this variable x. Okay. Let's access that and then print. Okay. So that's correct. Local variable is x. X has 10. That's what we store. Then the global variable x has 0, which is what we see here. Okay, right. So I hope the global and local variable concept is more clear. If I do not declare this, then what happens? Integer. I just call it x equal to 10. Let's see the output. Both are 10. So important thing, because x was declared here, x was the global variable and no new X was declared. So this X that we access and store and set the value to 10 is still the global variable. So calling here X itself is incorrect to call it local because it's still the global variable. Okay. And global X, if you try to access the with the namespace operator, then it accesses this value itself. Okay. So both of them you get to be 10. Just something to keep in mind. Okay. Right. Um,
Sir, what if we have a local X and
mhm. Yeah.
after that we want to update our global X
Yeah.
in the
You
main
can do that.
function?
We can do that. So normally we use like if we have functions to do this, we just pass that function. Um, One way to do that is you can, if you just pass the function, update it in that function and return the value, you can do that. So I can maybe cover reference if I have time today or in the next class. That's something I want to cover also. Uh, Here we can do one other thing is, yeah, like I said, there are various ways you can do this. You can pass it to a function. You can do it this way also, like X is something, and this the global X, you can maybe set it to 10 or something. So there are various ways you can access that variable and then set it. Okay. Now, one other thing one can do is maybe this way. So, right. Let me declare some specific namespace. So let's say namespace local and declare maybe integer x equal to 5. Okay. Now this guy is declared only inside um, the integer main, yes, but with a namespace local and there's an x. Like this x is inside some scope, its own thing. So one can try to this good one. Local x. So to access this x, I have to use the namespace. Before there was no namespace needed here to access the global scope because global scope we don't actually need to give a name. But here since I'm giving a name and I want to access this x, if I try to print this guy, what I would end up with. Undeclared local. Yeah, probably need to have this outside named and everything. But essentially, what I wanted to convey the idea is you can actually declare a local name space local, and then you can think of it like this variable is now in its own namespace. Okay, so you can access it like this also. Awesome. So x is 0. Awesome. Then there is namespace local. Integer is x5. So right, great. You have X in global space, X is in some namespace X, and there is a X declared local. So this is the X local, okay, the global space with colon, and another X that I access using the namespace local. Okay.
So one small thing, uh,
Yeah, go ahead.
as we created that namespace local,
Mhm.
so this has also a scope. Like
Yes.
मेन फंक्शन के अंदर हमारा वो काम नहीं किया, बट हमने उसको ग्लोबल कहीं ना
Right.
कहीं हमारा वो नेम स्पेस ग्लोबल
Right.
बनाया हमने.
Right.
So
So
that also has scope. Like can we
that,
create it locally also?
yeah, that scope is for the program. So you can think मतलब ऐसे सोच सकते हो कि main function का scope is within this bracket, yes. But to use this namespaces, one has to actually, there are rules. We can't declare it inside actually. You have to declare it outside and then access. So क्योंकि uh, because if you declare it outside main, now any code which comes later on. So let's say I declare previously जैसे मैंने Not this one. Previously when I declared this kind of functions. So hello is a function that I declared before using main. So now I can use this function. So essentially that that is required to access this sort of thing later on in your code. So यहाँ पर जैसे. So yeah,
Like we
that
cannot define our namespace locally in the main.
namespace you have that's the thing. It's opposite. You have to declare it globally. So this is the global declaration because it's outside main. Yeah. Now the thing is, it has its own this local has its own x, okay, declared and stored 5. So that guy uh, you have to access using local then colon x like that. Yes.
तो सर वन मोर स्मॉल थिंग, सो क्योंकि हम अपना नेम स्पेस ग्लोबली ही रख सकते हैं हमेशा, फिर हमें जो भी वेरिएबल बनाने होंगे तब वो भी तो हमेशा फिर ग्लोबल ही रहेंगे, तो वो हमेशा
Yes.
जब ग्लोबल वेरिएबल चाहिए तभी हम नेम स्पेस के साथ जाएंगे.
It's up to you. So जैसे मैंने यहाँ पर दो वेरिएबल मतलब डिक्लेयर किए. So this is technically a global scope, but you're accessing using a namespace. Here it's without a namespace, but still a global variable. वैसे.
यस, दोनों ग्लोबल ही होंगे. लाइक हमें अगर लोकल के साथ
Yeah.
जाना होता तो लोकल में हम फिर नेम स्पेस के साथ नहीं जा पाते.
Actually, I shouldn't call it local. I can just call it some custom namespace.
तो
So we
एक्चुअली
can,
लोकल इन द सेंस सर, जो
हाँ,
वेरिएबल्स हम यूज कर रहे हैं उनका स्कोप, अगर मेरे को एक
yes,
लोकल वाई चाहिए था इंट मेन
yes,
में, तो फिर हम
yes.
नेम स्पेस के साथ नहीं जा सकते थे.
No, then the calling that as local is not exactly correct. Yeah, it's actually better to call it custom namespace. Yeah, yeah, because local is only this variable.
यस.
Local for
हाँ.
this parenthesis for this main. Yeah, this is global. This is also sort of global, but inside some custom namespace.
ओके, सो इन शॉर्ट नेम स्पेसेस हमेशा ग्लोबल होंगे, एंड जो भी वेरिएबल्स हमको ग्लोबली चाहिए हम उनके लिए एक नेम स्पेस क्रिएट कर सकते थे.
Yes, yes. It's
लोकली
actually
चाहिए
good.
उनके लिए नेम स्पेस नहीं है.
Yes, that's actually good क्योंकि if you declare custom namespaces, then you can segregate them, uh, these variables appropriately. Yeah.
यस, एज वी डिड इन वीक 1.
Yes. Okay. I think can I mean end the class. If you have questions, you can ask. Else, yeah, can end the class. I'll cover references maybe next class. It's anyway we're almost out of time. I'll cover that from next class. Yes. That's also another very important concept to understand apart from pointers. So yeah. Any other questions? Yeah. Thank you.
Thank you, sir.
Thank you.
थैंक यू सर.
Thank you.
Thank you, sir.
Thank you. Yeah. Thank you. Thank you. Yeah. I'll share.
So one small thing, sir.
Yeah. Sure. Sure.
If you could share your mail if you want to reach you.
Okay. Sure. Usually, if it's um, questions, then you can ask in the forum related
Forum.
to. Yeah, you can ask the questions in forum. Yes.
Okay.
Yeah. Me or someone else will try to answer.
Okay.
Yeah, someone will try to answer the questions. Yes. If it's related to my something, I'll try to answer. Else, if it's in a general question, there are people who handle like doubts or something. So you can definitely ask them. It's sort of easier to how do you put it? Get your doubts cleared because this class will happen every week, every Tuesday. Also, every this class will happen from 6 to 8 every Tuesday. So you don't need to wait to ask questions. Well, I definitely encourage to ask questions here itself. But if you want to get something faster, like quicker, get your doubts cleared, definitely use the forum. You should have gotten a link from NPTEL. If not, then definitely write to their support if to get access to the Google groups. Join the group, ask the questions there, and somebody will definitely reply. Like get answer your question. Regarding the code files, yes, I'll share. NPTEL should share with you the code the folder with all the codes, like for every week. I'll also update it. They should share it with you. And definitely the lectures also. I'll upload this lecture also, uh, the video in YouTube. And they'll also, you should get that link, definitely. If you do not have access to any of these things that I said, definitely write to NPTEL. They'll help you out. Yes.
Okay, sir. Thank you.
Yes. Thanks so much, everyone. Yeah. Do practice. This is essentially the best way of learning programming is just by doing it. You have to keep like writing the code, run it. Do not fear writing code, because the more you write and then try to see the output and all, the more you understand. So you can make changes and see, okay, what if I do this? What if I do that? What does this mean? It becomes clear the more you actually sit down and write. Okay. So yeah. All right, I think we can end the class. Questions you can definitely ask in classes, and I definitely encourage to use the forum. Hope you guys enjoyed today's lecture also. And yeah, happy coding.